One of the questions I get from beginner programmers is how to break a problem down. Um, Usually be they'll see something on LeetCode or even Additive Code, um, and they won't know where to start or what process to follow. And so today I'm going to work through an additive code problem and show how I break problems down. This is going to be with Clojure, and Clojure also has specific ways of thinking about problems, but hopefully it will be transferable to other languages, and you'll see that it actually is fairly approachable. Um, so kind of let's dig into it, and I'll try to be explaining exactly how I'm thinking as I go. And today we're going to be doing the Advent of Code 2024 day one, and let's see how that works. Usually the beginning of every one of these problems is a bunch of flavor text, and so let's kind of dig into where it usually starts and decipher. So, upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discovered an assortment of notes and lists of historically significant locations. This perhaps seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Through the chief's office, the historically significant locations are listed not by name but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. So far, still just flavor. This is just one problem. By holding the two lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, so here is our puzzle input. So immediately I jot down, this is what our input abstractly kind of looks like. So let me put that on the right left-hand side here as our input. So input two lists, list one, list two. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. But pair up the smallest number in the left list with the smallest number in the right list, then the second smallest left number with the second smallest right number. So we're going to be putting these lists in order. So immediately I'm thinking to myself, well, I jot down, put lists in order, which means sorting. Um, Within each pair, so each number in each list, paired up when they're in order, figure out how far apart the two numbers are. You'll need to add up all of those distances. Okay, so there's going to be something about, pair up, calculate distance. And pair up a 3 with a 7, that's a 4, and so on. And then they go through the specific example. The smallest number is 1, and the right list is 3, so that's going to become a distance of 2. And they go through. We'll come back to this later to verify. And then we want to find the total distance, which is summing between the left list and the right list by adding up the distances between all of the pairs you found. In the example above, it is 21025, a total distance of 11. Now I'm re-recording this because my first recording failed halfway, so I've already solved this, but we're going to try to do it again completely from scratch. And so the total distance, the final answer, which in our example is 11, is our output. And to get to that, we sum things up. Now, often when people start approaching problems like this, they start thinking, okay, here's our input, and what functions do I need to do to get towards our output? But instead, the approach that I'm proposing is actually thinking purely of data structures. How do we take our input? How do we convert it to something that's easy to work with? What do we want our data structures to look like at each step of some process? And then how do we maybe get to the output? So to do that, you really don't need to know anything about what functions exist in your programming language. You just kind of have to think of how could you represent the data and how might you want to transform it. So to start, I copied over the input into a file because our final input is going to be very big, much larger than our sample input, but we'll work with our sample input first. So let's get that into our program. This is kind of what it roughly looks like in the file. but to get it into our program, we can slurp it, and I have it under AOC 24 or just 2024 day one sample.txt. And our input actually looks like this. It is a single big string with with spaces separating the numbers and new lines separating each line. And I'm gonna just write that down here approximately like that. We had 3, 4, 4, 3, and so on. And that's where we're starting. And we know we need to get to 11, and we know we need to do some transformations in between. And so we can kind of next think about, well, what this is how the data that we're working with, and I want to be thinking, what does my data look like in each of these steps? What do I want it to look like next? Um, and so seeing as how this is how we're getting our input, the first thing I want to kind of basically decide is that's not, I don't want to be working with the string directly. It would be nice instead to work with two lists, 3, 4, 2, 1, 3, 3, and 4, 3, 5, 3, 9, 3. So we're going to have to go from this string to these two lists, because that will be much nicer to work with, because that's actually two lists. That's how we would represent them in using Clojure data structures. And then we can kind of think about what is the problem asking of us, and what would we want to do next. So the problem mentions once we have these two lists, we're supposed to kind of match them up from the smallest number in each list with the smallest number of the other list, and so on. And so the next, what I would want to do if I had this, just on a piece of paper in front of me, is I would want to convert these two lists into their sorted representations. So 1, 2, 3, 3, 3, 4, and 3, 3, 3, 4, 5, 9. And now that we can mention that that's kind of roughly what we're doing, put lists in order. Next, we want to pair up the numbers from each list and calculate the distance. And so maybe we could do this as follows, where we have them as pairs, 2, 3, 3, 3, and so on, where we've paired up the first of each list, the second of each list, to make our pairs here. So that would be nice. And then after that, we want to calculate the distance. So I'm going to split up this pairing up and calculate distance into two steps. And calculate distance. So for each of these, we're supposed to calculate a distance, and so that might look like something like this. So the distance there is 2, then the distance those is 1, distance 0, and so forth. And once we have the distances, we can sum them up to get our output, which is 11. And so far, we haven't been thinking about functions. We've just been kind of reading what they're doing and recreating it in terms of the data structures that we might be comfortable working with and manipulating in our programming language. So that's why we started with our string, because that's what's kind of given to us. We turn that into something that represents what the problem kind of is talking about, which is two lists. We sort those lists, we pair up the numbers in each list, we calculate their distances, and then we sum it up. And now we're at a stage where we're going to have to think about how might we go, what functions might we use to go from each step to the next. Now, all of this work that we've done so far, I would probably do in my head in just a few moments, but that's because I've been programming for a very long time. And so if you're still just starting out, I do recommend explicitly just writing it out, just like we've done like this. And then we're going to be filling in the blanks, because seeing it in front of you makes it much easier to think about rather than trying to keep it all in your head. And sometimes as you're working through the problem, you realize that you might have missed something, or that it might not be so easy to go from one step to the next, and that's okay. That's just a sub problem that you found that you will dig into. And sometimes you might start working on a problem and not have the full plan planned out like we have here. The problem will be too big to do that, and that's okay. You can just start working on it, and then you start seeing what the problem is as you're working on it. But we have a roughly entire plan here, and then so let's kind of get started. Um, we have so we've our slurping ends up with this string, and so the next question here is how do we get to a list like this? And we might actually the next bit might this might actually we won't be able to do this all in one go. We'll probably want to first off just split on new lines. That's something that we can do, which will give us something that looks like this, or 3, and so on. Um, and then, well, let's start there, and then we'll see what we need to do to get there. So I'm going to start with a double threading macro here so that I can do each of my steps. And I will immediately, after each of the steps, put exactly what an example of what the data looks like. So this is what we have, our string. And so given this, how might we get to here? There's a, and this is where now the actual doing of these things requires some knowledge of what are the different functions available in Clojure, as well as the different ways of maybe combining them. And that's something that you learn by um, being shown solutions to exercises, just reading of the various functions, and asking for help sometimes to fill in the blanks. But you like some of these things you can't know until you're shown the first time. And so maybe for some of these steps that we're doing today, it'll be you'll be able to already jump at the next step, and that's great. And then for some of them, you'll be like, well, I don't know how we're going to go from this data structure to this the next other representation, and so I'll be the first one showing you. Okay, so here to go from this string of line that has multiple lines in it to multiple strings in a list or a vector, the function that I want to use is split lines. I just know that that will do the job, and I can import it. Split lines, and that should have imported at the top. So let's evaluate and let's see what that looks like. And indeed, that looks like what we wanted, what we expected here, which is now a list of strings rather than one big string. And I'll move that over here, that comment here to show us what we have so far. And now we want to go through this list of strings into these two lists. Can we do that in one step? Probably not yet. So perhaps as the next thing that we want to get to is it'd be nice if we had them as actual numbers, because we know we're going to need to work with them as numbers. So, or, well, at some point, yeah, we probably want to get to something like this. But even then, it's not immediately clear how I might jump from this to that. So perhaps we could instead first go from that list of strings to pairs of numbers as strings. And that now might be more approachable. I think I know how to do that, and I think I'll know how to do that. So how do we go from here? So here we have a string, three space 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 4. Here we have two strings in a vector. And so now the subproblem really is, well, I can think of it as I need to figure out how to go from 3, 4 to vector of 3, 4. And if I can figure that out, then I know that I can just do that to each of these. And to do that to each of these, you know, I can do that with mapping. So anytime you have a list of things that, and then you want to transform each item in that list, then you want to use the map function because that's what it's for. And now in terms of how I might go from this to this, I know that, well, I could split again. I can use the split function. I could potentially use the regex function, but I'm going to use the split function. So I'm going to create an anonymous function here. So here is our like number string, and I'm going to say string split the number string on. Now I could double check if there's an exact number of spaces, but I'm just going to say any number of, well, let's just call them any number of spaces. And let's see what that gives us. It gives us an error, but that's probably because of this down below here. Let me try that again. Error printing return value. Let me take a look if there's any more information for that. String cannot be cast to pattern, right? This has to be a regex, not just a string. And we get what we're expecting, which is now this vector of these vectors of strings. And now we need to do the next transformation. How do we get from this vector of vectors of strings to a vector of numbers? And once again, I see that as a mapping. We're definitely going to map something. I mean, we would call this the pair of strings. Or maybe we immediately just think we could destructure here. And we could say we're going to have the string A and the string B, and we want to get the numbers for them. So maybe we could do, we want to return a vector of parse long of A. Parse long is how you convert a number to a string, an integer at least. But we're doing that to both of them, so maybe actually we could call this strings, or pair of strings, and we can once again map on the inside. We can do map parse long pair of strings. Let's see if that does what we want. And so yes, now we have a list of lists where each list is a pair of numbers. That's still not quite what we want, but it's getting us closer. And you might notice these are vectors, and it's actually we're getting lists. And for today, we will ignore the distinction between those. We'll treat them both as the kind of same thing. But let's now think about, given now that we have this kind of lists of pairs, how might we get to a list of two lists like this so that we can move on and sort them? And this is one of those situations where I notice, because of my experience, that this is the transposition problem. Um, if you have, like, what we're wanting to do is kind of change rows into columns or columns into rows. You know, our data is like this, but we actually want to rotate it so that it looks like 4, 385, 393. So we want to go from this and to basically rotate it 90 degrees. This is called transposition. You can do this in like when copy pasting in Excel. There's a way to like paste with transposition. And Clojure doesn't have a transpose function, but I've done this enough times before that I know how to write one. Um, and again, this is one of those things that as you're, you know, over time, you learn functions that are available to you as well as little micro solutions. Like, so there are functions that you might have to implement yourself, but that you can reuse and build up to solve problems. And so this is an example of that. And had you not seen that, then you might have been stuck here. And so part of programming is just learning the various, like, building up a tool belt of functions that are just in the standard library as well that you're aware of, as well as little combinations of those functions. So what does transpose look like? I know that you can implement transpose doing apply map vector data, and this is just kind of memorize this at some point. And as an example of using it, here is we're gonna have 1, 2, 3, and 4, 5, 6, and it returns. Oh, missing an S here. 1, 4, 2, 5, 3, 6. So here we see that we've turned, like, instead of having a 2 by 3, we're having a 3 by 2 list. Like there's so the number 1 is here with paired up with the number 4, 2 is with 2, 3 and 3. And as homework, I encourage you to try to understand how that's happening, how that transpose is implemented. But we're just going to continue on. So let's toss this transpose in here and see if it's doing what we want. And indeed it is. We now have our two lists. So we finally kind of taken our input, parsed it, and manipulated it to a point where we can actually be approaching the problem. So I'm going to move that comment here so that we remember that's what that looks like. And let's continue on. So the problem asks, if we remember, the problem asks us to put these lists kind of in order so that we can pair them up, pair up each number. So let's do that. We kind of plan to kind of sort each of the lists. And so our input to this subproblem is this list of two unsorted lists, and we want to end up with a list of two sorted lists. And so once again, that's going to be a mapping because we're going to be applying the same operation to both uh, items in this list. In this case, the items themselves are lists. And what operation are we applying? It's going to be the sorting operation. So we can sort each of these lists. So this list will be sorted to become that one, and this list will become sorted to become that one. And double check, and indeed our code is doing what we expect. And next up, we planned to pair up the numbers, the first number of each list with the second number with the third number. And how might we do that? And here I'm noticing that this is the reverse of what we did in this step here, where we were taking like these pairs and kind of building up lists with them, and now we're doing the reverse of that. And we can actually do the reverse of that with transpose again. Because if you transpose something twice, you get back to the original. And so, basically here we were turning rows into columns and columns into rows, and here to get to the next step, we want to do that again. So that's something we just need to kind of notice, and we can reuse that function. And indeed, here we have 1, 3, 2, 3, 3, 3, exactly as we expected. And next, our plan was to calculate the distances for each. So we're converting each pair into a single number. Once again, we're doing something to each item in a list. So immediately we reach for our map. We might say we have our pair here of A and B. And to calculate the distance between A and B, if we have two numbers, this is kind of a sub-problem to solve. And if you kind of look up the definition of a distance, it's one number minus the other. Now that will occasionally give us negative numbers, and we don't know which one is the bigger one or which one is the smaller one. So I know that we are supposed to take the absolute of that. Now, this came quite quickly and easily for me. You might have had to take a moment to just break down the question of distance, and maybe you make it into its own function and just test it out on its own. So distance of A and B. And we might just take this and re-implement it above here. And you might want to write some code to double check that. So like distance of let's say 5 and 1. Oh, the function is not defined. Whoop, arity exception. So actually here we were expecting a vector. Let's just make that take 2 arguments. So distance between 5 and 1 is 4. Distance between 1 and 5 is 4. So that's good. And so we can use that down here. Distance A and B. And let's run this whole thing. And indeed, we're now getting 2, 1, 0, and so forth as we expected. And now that leaves us with our last step to just sum things up. And so once again, we have this a new subproblem. So the input to this problem is we have a list. We want to sum it up and get a single number out of it. And if you don't know how to do that off the top of your head, you would have to potentially look it up, because this is pretty much as broken down as things can be. And so you would have had to have seen that in order to solve this subproblem, you probably, you can do that by using apply and plus, because the apply function can, or the plus function can be used to sum up multiple numbers, but we have a list, and so we have the list 1, 2, 3, 4, which we can combine with the apply function and plus, and that will give us the sum. Let's see how that happens in action. There we go. We have the number 11, which is what we expected. Now that we have our code working with the sample data, let's try it with the real data and see if it gives us what we, well, and then submit and see if that matches what we have in Advent of code. And so that gives us some number. And again, I did these before. I'm re-recording this. And so I can't submit it again, but I can double check that indeed that is the correct answer. Hooray! And before we move on to part two, let's just kind of review our approach here. We read the exercise. We kind of tried to identify the input, roughly the steps and the output that they're asking us to do. But rather than just immediately thinking of the functions, uh, we broke it down in terms of what does the data look like, because that doesn't, then we don't need to know the functions yet. We just need to know, like, well, this is what we would like our data to look like, and hopefully that's something that you can always be able to do, because it's just, working with lists and numbers and strings and combinations of lists and hash maps. Like, that's pretty much the kinds of data structures that we're working with. And so you're just kind of thinking about, given what they're asking us to do, what kind of what do we want our data structures to look like? And then once we have a rough plan of what those data structures are going to look like, we can pull up and try to think of each of those things as little subproblems and try to find what function might be best to solving them. And occasionally it turns out we have to do it in multiple steps. Like, I thought originally that we might go from our string immediately to our two lists of numbers, but it took multiple sub steps, and that's normal. We just kind of keep breaking down the problem as far as we know, and then sometimes when we're tackling a sub problem, it might turn out that that sub problem can be broken down into further little sub problems. Let's attempt part two now, and we're going to do the same thing: read and then break it down and try to solve it. So part two. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different, or are they? The historians can't agree on which group made the mistake or how to read most of the chief's handwriting, but in the commotion you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. That's just flavor. Nothing really important here. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. That was a lot of words. We'll double check what that means by maybe looking at the example. So here, there's our same sample as before. And here's how to find the similarity score. So for the first number in the left list, which is the number 3, it appears in the right list 3 times, and so we multiply the score together to get 9, and then we do the same thing with the second number, which is 4. It only appears once, so we get the number 4. And so for each of these, here with 2 appears 0 times, so for each of these we count, for each number on the left list, we count how many times it appears in the right list, and we multiply it. And we do repeat that for the number 3, which appears, so again, that's going to give us a 9 and 9, so we get multiple 9s here. And then once we get each of those, what they call similarity scores, we add them up and for a total similarity score. So this doesn't actually seem like it has much to do with part one. I mean, we're using the same input, but the operations we're performing sound very different. Sometimes in advent of code, they're like, part two is just a small change to part one, depending on how you wrote part one, but sometimes it's just kind of redoing some or doing some new work with the same input. So let's break this problem down in a similar way. We label that as part one. This is going to be part two. Our input is going to be the same. So we know we're going to be starting with the same string. And probably we're going to want to think of it as two lists again, because that's nice to work with. So we're going to do whatever we did before to get to this stage of having two lists of numbers. And at some point, we know we want to get to this 940099 so that we want to be able to then sum them up to get to our final answer here. And then we can review how do we get from the list to this. And we had each number with the number of times it was counted. So that's something that we could potentially represent. We could say, well, in the first list, the number 3 appeared 3 times. The number 4 appeared once. the number 2 appeared 0 times, 2 appeared 0 times, 1 appeared appears 0 times in the second list, and so forth. So that is just kind of what they were showing us here, 4, 1, 3, 3, 4, 1, 2, 0. Going from that to that is just going to be multiplying each pair. Going from this to this is potentially going to be a little tricky. We have to think about that. And so what they're asking us to do is for each number in this list to look up how many times it appears in this list. And how many times something appears in a list, that makes me think of calculating the frequencies. And in Clojure, there's actually a function called frequencies. And so I know that we could, using frequencies, get something that looks like, so if we took frequencies of this, we could get something that looks like this, which is going to be 4 appears once, 3 appears 3 times, 5 appears once, and 9 appears once. Maybe with commas, that'll be easier to see. Let's actually even, I'll show that. And so this might be useful because then if we have this, we can just look up, hey, how many times does 4 appear? It appears once. So having that as a kind of data structure that's available to us will be useful. And so maybe then having this list and this hash map, it will be, I think, fairly possible to look up, because the first number in each of these is just the number in this list, and the second number is just a lookup of what's in the hash map. So I roughly have an idea of map with some function of going from here to there and from this list to that list. So at this point, this again might have happened in my head very quickly. For you, you might have to write it down and think it out loud just like this, but then once you have a rough plan and you think that you can kind of perform each of these steps, we can now actually start coding. So let's get into that. And we haven't had to, we thought a little bit about some functions, and knowing of the functions helped us kind of break down the problem a little bit. And so that's kind of this process. You get better by learning and of different functions and different combinations of functions. It kind of builds up and helps you break down problems. But even without that, hopefully, even without knowing the functions, you can still break things down purely based on what you might want the shapes to look like in between each step, the shape of the data. So let's dig into it. The first few steps are identical from before, so I will just copy and paste so that we can get to this stage here where we have our two lists. And let's just double check that that indeed is working. Oh, it's using the real data. Let's bring back the sample data. That will be easier to see. Excellent. So that is looking nice. So in the next step, we wanted to work with the first list on its own, which was this one, and then get the frequencies for the second list. And so now that we're going to be working with two things, we might actually need to break out of our single linear list and give those things names. So I'm gonna take this whole thing that we have so far, and let's just call that, or maybe we call that our lists. And we might then break down, we might call the first one list A and the second one list B. I'm just going to destructure. So now we're going to have basically the first list in the value list A, the second list in the value list B. List A we want to keep as is, but list B we wanted to get this map of frequencies. So let's just do that. Let's maybe call that counts. And we call frequencies on list B, and we can double check that that is returning what we want, which indeed it is. And let's just, for clarity here, we can make a comment like that. And if we really wanted to make things clear, we can put our two lists down here as comments as well. And again, something that you might not do as you get more comfortable programming, but at the beginning, I highly encourage to put these extra comments so that you can see what these things would be at every given step. And so now that we have this, we have list A and we have these counts, how do we create this list of pairs here? And the thing to notice is that for every item in list A, we're making one of these pairs. And so this is, once again, we can think of this as a mapping. We're mapping from this to that, from this number to that. So let's start off with our list A. And once again, we're going to do a mapping, and we're just going to call that each number maybe just the number X. Or let's call it A because it's from list A. And we know we're going to want a vector of that number and something else. So maybe I'll just start off with that number, and we'll just put a placeholder there called X. And let's just see what we have here. So we have now a list of 3 and X, 4 and X, 2 and X, which is exactly what we want. And now we need to figure out what that other number is. And that other number was the number of times the first number appears in the second list. And we can get that from our counts. So we can do counts of counts of A. We can see what that looks like. So that is 3, 3, 4, 1, 2, nil. Now we're seeing nil here instead of 0, and so we might want to make sure that's 0 because we're probably going to be wanting to multiply and things like that. And so let's change this. So instead of just looking up counts of A, we can use the get function to also look it up. So that hasn't changed anything yet, but the get function allows us to give it a default value. There might have been another way to do this. We could have used or something like or. Yeah. So we could have done maybe or counts of A and 0, but using get also works. And now that we've gotten to this step, which is what we wanted, let me write that down here. And so next we want to multiply each pair. And so once again, this is a mapping because for each item in this list, we are performing the same operation, which is to multiply the two numbers together. And so we're doing a mapping. We could maybe say here are numbers A and B, and we're going to multiply them together. And we're getting what we want here. Let's just put that down as a comment. And finally, we just need to sum them up to get to our final answer. And so our problem is we have a list of numbers and we want to sum them up. This is, we have that exact same sub-problem in part 1 at the very end. And so we can do that in the same way, which is just to apply addition. And we should get the number 31. So let's evaluate and see. And indeed, we are getting what we want. That matches up with what they told us. So now let's take this and run it on the actual data. And we see that the numbers, some series of numbers, and that does match up with the actual correct answer. Great. And so once again, the way we approach this is to kind of think first about what we want the data to look like at each step. And that way we don't have to think about what functions are we using. We're just thinking about how we might be manipulating the data. What are we going to be changing the shapes? Sometimes occasionally introducing new kinds of shapes or working with multiple shapes at the same time. And only then we have to think about how each of those little sub-problems might have to be solved using functions that we are aware of or that we might have to look up or ask someone or ask ChatGPT. And like I mentioned before, the first time you have to kind of be shown or become aware of these functions. Now, the things that are in the standard library, you can just look up and look at the documentation, look at cheat sheets, and just become aware of everything that's available to you. But then there are a whole bunch of other things that are combinations of those, or that they might not be in the standard library. And earlier we saw that as transpose. For example, we had to implement our own version, but it still relied on us recognizing that the problem we were trying to do was this transposition problem. And if you didn't know that, then you might have been stuck. And so at some point you kind of build these up. But if you didn't know that and I showed you that, that's great. Now you have that under your tool belt. If you ever have a list of lists that you need to rotate, you now know how to do that. And, eventually you might not have all these comments, so your code might look a bit uh, briefer. But for things like advent of code, where these steps kind of don't have names, they're all kind of just like arbitrary instructions that you're supposed to follow. It helps to kind of leave them around so that you can look and understand them later. And now, if you had approached this problem differently, you might have ended up with slightly different code. There might have been certain steps we could have skipped. There might have been a way, for example, to immediately like go from not have to have this representation of pairs and instead directly jump from one step to the next. If you recognize that and you see that, that's great. Feel free to skip those steps and jump to the next step immediately. But if you're just starting out and having a trouble breaking down these problems, then doing every step explicitly, if that's what makes it clear and simple for you, then do that. Great. Hopefully that was useful, and I encourage you to try out this process when both to puzzles like Advent of Code, but also generally to programs. This is the way kind of I think in my head. A lot of this work is happening in my head rather than explicitly written down, but it's still kind of I'm still thinking in terms of shapes of data. What are the next shapes that I want? And then thinking about what functions, how do I get from one shape to another? So it's kind of data and shapes first, and then thinking about what functions to get there. So I'm breaking things down without having to necessarily think about functions. I'm breaking things down just purely thinking about shapes and how they're organized into other shapes of data and how they're organized. All right, see you next time.